So we're in the test principle now, and I'm just going to go ahead and save this new expression. So this is where we're going to test the flat vendor that we built, or the vendor that will contribute a rather flat design. Now there are many different variations of program that we could create to check whether a bit is being successfully added to an array. I'm just going to choose a simple one with hard-coded bit indexes, rather than reading them in from standard in. I'll set one index, say, to be inside the bounds of the bit array and one to be outside the bounds. So each construction site will be triggered for the bit added and indexed out of bounds, and we'll be able to see whether everything works as it should. So here you can see that the test principle has already contracted our own newly built vendor. Nobody else in the marketplace can contract this guy yet. He's only available for private contracting by us. Only once we're happy that this guy does the right job will we publish to the Valley, and only then will anyone be able to actually contract him. So since I want to add a bit twice, once when it will succeed and once when it will fail, I'm just going to contract myself again. I'll just say now for the test elf, we're going to need a new Linux program. So I'm going to contract contribute Linux program. We'll also need an exit. So I'll contract a call Linux exit. And I'm going to contract the variation that will write a success. We'll also need a new number for the bit index itself, so I'm going to contribute an integer. And I'll contract myself, another vendor that I've done up. So and we'll need a new bit array, of course, so I'm going to contract contribute bit array. And I'm going to do a simple write to standard out in the case where the bit is successfully added, and then in the case where the index is out of bounds. But to cover all cases, I'm going to have to contract 4 writes. Cool. So in the first case, we want to write in the success or fail cases when the bit should be successfully added, and in the second case, we want to write in both the success and fail cases when the bit should not be successfully added. So string to stand it out. Contract that again. Cool. And again. Going to be paying myself a few little satoshis. Last time. So, right bit added 1 and 2, right index out of bounds, first one, and the second one. The last 2 vendors I need are the sets. So they are going to set the index to an inbound value, and then we're going to set it later to an out of bound value. So we'll contract 2 set integers. First one, set index. Now you'll notice that there's no processing panel over here, and that's because this isn't a vendor principle capturing requirements for suppliers and committees. We're actually contracting suppliers and actually organizing committees. We're not in the design time of a vendor. It's now design time of the program that we're building. and runtime of our vendor. So there are no nouns because that information is being requested from us now live. So that's these fields here, the specs. So I'm going to go in and fill those in now. The add to array doesn't have any specs, as we know, we just expressed it. Neither does the new program, neither does the exit. The new number for the bit index is asking us for the minimum and maximum values of that number. So let's just set these to say 0 and 100. I'm just going to write that up here as well. Just for a quick reference if I look back later. The new bit array asks for the maximum number of bits. Let's say 70. And the write, the first one, wants to know what we want to write. Let's just say bit added. We want to write that twice. And then we want to write index out of bounds and index out of bounds. And the last two guys we contracted were the sets, which are requesting the constant that they're going to set the number with. So the inbounds case, we just have to make sure that it's within bounds of the bit array, which we know is 70 bits long. So I'm going to set the index inbounds as, say, 60. And the out of bounds, let's say 80. So we're almost done. I might actually also contract so that I can actually see the bit array myself and see that the bit has been set. I'm going to contract a call Linux write bit array to standard out, which will write a human readable bit array. I'll need 2 of those, so I'll go contract it again. So now we can go ahead and organize all these docs. So first I'll organize the initialization work at the start of the program in the main flow. So this supplier new program provides us with a chair flow. So the main flow. So I'm going to create a committee for that. That's now organized. And I'm going to initialize the bit array in the integer here. Then we're going to go ahead and set the index to the out of bounds case, say. Let's do that one first. And then we're going to add to the bit array. As we know, our add to bit array supplier, which is us, provides 2 chair flows, one for if the bit was successfully added and one for if the index was out of bounds. So I'm going to create 2 committees, one for each of those. Bit added, index out of bounds. In the case where the bit is added, I want to write bit added. In the case where the index is out of bounds, I want to write index out of bounds to stand it out. Just minimize those. Then, regardless of success or failure, I want to write the bit array, which ideally should not have any set bits in it. Should be all zeros, human readable. Now in this case, we know our supplier requires the bit index and the bit array. So I'll create 2 committees, one for the bit index, that's that integer, bit index, and that's what that set integer also requires access to, understandably, to design that integer. And a committee for the bit array. So there, that's all organized. So now I've handled the out of bounds case. Let's go lay the code down for the inbound case. So we now want to set the index to an inbounds case, the 60, and then we want to add to the bit array again at that index. Then we have 2 more chair flows, one for if the bit was added and one for if the index is out of bounds. Again, I'm going to do a write in each of those cases. And write index out of bounds. Those are done. This add to bit array second contract requires access to the bit index, of course, which is this, which has been reset. And the bit array. Finally, we want to do a write of that bit array to verify that the bit was successfully added. And then we're going to exit the program. And I'm just going to do my usual tidying up at the end. If we try to build and something outstanding hasn't been organized, the principal will let us know. Like so. I forgot to put the write bit arrays in touch with the bit array designers. Now they're all on the right committee. Just going to minimize all those. That looks good. Minimize all those. Excellent. I'll save that. And I'll just do a quick assessment. The build cost is 9,500 Satoshi. We can quickly convert that to millibitcoin. So it's under 10 cents. We're breaking the bank here. Now I'm going to build. Now the test principal is going to ask me which version of my vendor I want to build this test using. I've only got one so far, the one with the flat design. So I'll click that and hit build. Yes.
Building.
And now let's go check the portfolio.
Construction complete.
Which we know is built. Excellent. So there's our new test expression that we've just saved. And there's the corresponding build. So let's download that elf. So after making that executable, we're going to now run up the program. So let's run it up. Looks good to me. So you can build as many tests as you like, basically as many as it takes for you to be confident that your vendor works. Then hit publish and you're off. So I'm going to go publish. Now before I hit publish, remember that tentative price that we set when we added this supplier to our portfolio? I just made it a default 100 Satoshi. If we inspect our design for a quick summary of our suppliers, in total, every time our own vendor is contracted, it's going to be forking out, as we know, 1,400 Satoshi to its suppliers. So I want to set my contract price to at least be 14. I'm going to employ great business practice here and have a profit margin of 1 Satoshi. I'll update my price, and now I'm going to publish this vendor. So if we jump back to the valley and drill down to that classification, to bit array, you'll see, voila. We've got a footprint of 227 bytes. Our contract cost is the 1,401. We've got 2 contracts so far, and we know who those are from. They're from us. But at least then other people browsing the valley know that it's at least been contracted more than once, which is probably the test contracts, but nonetheless, at least that developer has done the due diligence and tested their vendor before deploying.